Okay, we're continuing taking a look at relations and functions. Well, functions really. Remember what a function is? That was our special machine. If we put something in, we get one thing out, which is functional. That would be weird if it made two things. So that's a functional machine. So now we want to be able to be sure we can read a function and understand the language. If you are a function, you get that special notation, like f of x equals x plus 2. That would be a function. It gets this notation. That's still just y. But what it allows us to do is tell us what we're putting in the machine. So let's read this. If I'm putting 2 in the machine, it means I put a 2 in for x, and all I'm looking for, the answer is the y. It's the 1. I put in 2, I get 1. Remember, it's still just an ordered pair. I put 2 in the machine, and when I put 2 in for x, what comes out is 1 for y. Now this one's just asking me to go the other way around. If the machine spits out a 4, that's a y. Well, what x made that happen? Well, it happens at -1, and it happens at 3. So remember, they're ordered pairs. So the reason I'm showing it like this is I want you to understand this is not violating the rule of a function. 1x going in goes to 4. Only one thing came out. That's all right. 3, same for 3. 3 goes in, only 4 came out. Now it repeated. There were two ways, but only one thing came out. All right, they're just showing us what I just did. Okay, if we use that same figure now, we're just looking for an output of 1. So I should go back here. So when does 1 come out of the machine? Well, that's at this spot right here. So that's the y value. So the x is 0 and 2. Now I'm going to write them. This isn't really what they're, oops. So when 1 comes out of the machine, 0 could make that, or 2. Do you see what I mean? Okay, now they're talking about what is a one-to-one function. Now this is even more special machine, even more special. The specialist machine, I don't know. But what it means is this. Not only can you put something into the machine and you get something out, one thing out the other side, there's only one thing you can put into the machine to get one thing out. Now I hope I haven't ever said it wrong, but it's you got to be careful in the way you say it. A one-to-one function is a special machine where there's only one thing that comes in that makes the one thing that comes out. So let me see where we're going to this. I want to get to something. Well, I don't like any of these examples. Let's go to this. Now, if I made this line, it would look something like this. If you can see here, no matter where I am for x, there's only one x that makes each of these y's. One x. But if you were to look at this, we even saw this already. So suppose this is 2, or let's make it 3. Okay, so how do you make 3? Well, there are two x's that could make 3. That is not a one-to-one function. There can only be one way to do it. And so actually, if you see the graph, what you look for is that it just keeps increasing or keeps decreasing. If it overlaps at all, that means that there are two x's making a particular y. Now we'll see a trick for this later, but let's keep going. I don't really like this illustration, but this is not a very good one. A simple illustration, I'm going to skip it. A simple illustration is, like I said, it's just a line. Every x that goes in spits out only a single y. It will never repeat. There's no two x's that are going to make the same thing, because a line is always either going up or always going down. So a super special machine called a one-to-one function, there's only one thing you can put in to create every unique thing that comes out. Okay, I don't know, I don't love all these word versions of this that they do, but let's talk through it. So is a balance a function of the bank account? Okay, so you've got the balance. Is that a function of the account number? Okay, so I'm putting in my account number. So I'm putting account numbers into the machine, and I'm getting the balances that are coming out the other side. So can an account number ever have two balances at the same time? No. So this is a function. So we're good. This is a function. Now let's look at the second one. Can an account number ever is a function of the balance? Okay, so I'm putting a balance in and the account number comes out. Well, what if I put in $100 into the machine? Isn't it possible that there are lots of different accounts that have a balance of exactly $100? So B is not a function. Now they're going to ask us this one. Okay, so back to number one where we were looking at this. Is this a one-to-one function? So what I'm going to do is put in your bank account and then I get out your balance. I'm going to put out my bank account and then I'm going to get my balance. Now what I want to know is there only one account that I put in that gets out that one balance? And the answer is no. It's possible that two of us, so I put in my account number, so our X's are okay, but maybe we both have a balance of $100,000. So this is a function, but it's not one-to-one. Every account would have to have a unique balance, which isn't the case. Okay. So letter grade, a function of percent. I should write it. Letter, a function of percent. Okay, so I put in your percent. You got a 70. Well, you're going to get one letter grade out. You're going to get a C or a C minus or whatever it is. So this is a function. Now the question is it a one-to-one function? So every percent that goes in, is there only one way to get the letter C? No, this is not a one-to-one function either. If I put in 70 or 72, those are both C minuses. So that's not a one-to-one function. It is a function, but it's not one-to-one. All right, now if you want to know whether something is a function, a really easy way to tell is you draw vertical lines. So I draw lines. Imagine I've got this line. I can move it up and down across the x-axis anywhere. If you hit the graph, the picture, only one time, you got a function. Why is that? Because at a particular x, I'm getting out only a single y. So you see here, I've got my vertical line, I hit it only once. That's a function. 1x, 1y. If you go here, 1x gets me 2 y's. That's not a function. And here's an ellipse, but it's like the same with the circle. 1x gets me 2 y's. It fails that vertical line test. All right, let's test these real quick. If you see what's happening, now this means it's going on slowly forever with those arrows. So this is a function. It would never, a vertical line never hits twice. So function, here's a line, would never hit twice. Function, circles, no. Okay, now if you look at this, you do your vertical line test, that's a function. It would never hit the line twice. Now the horizontal line test is a way to find one-to-one functions. I kind of already hinted at this. So a one-to-one function, 1x makes 1y. So if I go horizontally, I'm never allowed to have two different ways to make that y. There can't be. It has to be unique. So a horizontal line, if it hits the line twice, is saying there are two y's at this moment, and it's not okay. So it's not a one-to-one function. So I don't know why they have this. It is not a function, and if it's one-to-one, it's also not one-to-one because I'm hitting two places with the horizontal line. Okay, now that's an introduction to functions. In our next section, we're going to spend more time talking about their domain and their range, which is a really important idea.